Hello and welcome to Clear Water Quality. In this video, I'm going to go over an example of silver chloride solubility where we are adding the silver and the chloride in different amounts and we want to calculate how much is going to precipitate. Okay, so we're going to have a solution that has 10 to the minus 3 moles per liter of silver, and then we're going to add the chloride such that it has a concentration of 10 to the minus 2. And we want to know what the final concentrations of silver and chloride is, which means we want to also know how much precipitant is going to form. So I'm going to draw a schematic so that we can see what this looks like. I have a beaker of water, and I add in a water surface. And in this solution, I have silver present and a concentration of 10 to the minus 3. And then I'm going to add in the chloride at a concentration of 10 to the minus 2. So some time period later, got the same beaker, my water surface, and a precipitant forms, silver chloride precipitant, and my silver concentration is now 10 to the minus 3 minus whatever precipitated. And I'm gonna define a variable here. Let's see, which is that X is equal to the moles per liter of silver chloride solid that precipitates. And so then this is 10 to the minus 3 minus X. And the silver and chloride are both present at a 1-to-1 ratio in the solid, so I don't have to, put any multipliers or anything like that. My chloride concentration is 10 to the minus 2 minus X. To solve this problem, I am going to use the equilibrium constant in the mass action equation. I have KSO is equal to silver times chloride. And I can simply pick off these expressions that I've defined over by my schematics. So I have 10 to the minus 3 minus X times 10 to the minus 2 minus X. And my KSO value is 10 to the minus 10. So I can solve this using a solver in my calculator or using a spreadsheet or something like that, or I can use a quadratic equation. So I'll show you that. So I have 10 to the minus 5 minus 10 to the minus 3x minus 10 to the minus 2x and then plus x squared. So this gives me x squared minus and 0.011x plus 10 to the minus 5. And I get an x value that's really small, but this guy is like 0.000999989. And if I take the log 10 of that value, it puts it into the 10x format. And I can do that. So this is the amount that's precipitated, but the question is asking for the concentrations of silver and chloride. So then I need to put them back into the expressions over by my schematic so that my silver is 10 to the minus 3 minus x, and the x is above, and my chloride is 10 to the minus 2 minus x, using the x above. When I solve this, I get a value of 10 to the minus 7.96 moles per liter. And for this one, I get 10 to the minus 2.05 moles per liter. And don't forget to carry a lot of numbers on these problems because we're dealing with really small numbers here. Okay, so this gives me the final concentrations of silver and chloride. So final concentrations after precipitation occurs in this solution where we have silver and chloride being added separately.